In this video, we'll be looking at section 0.3. Radicals with variables. So we're going to be introducing some variables into our radicals, and we'll figure out how to deal with those so we can simplify. So our essential question is, how do I simplify when a variable is under the radical? But before we begin, we'll have to do a little bit of review. It has to do with our exponent rules. So one of our exponent rules is when I'm multiplying similar bases together, we add their exponents. When I multiply like bases, I add exponents. And the other review we'll need to do is when we're dividing like bases. So that's review 1. Review 2 would be x to the 4th over x to the 7th. So we subtract their exponents. And wherever there was more of them, that's where it will stay. So what I mean by that is since I had x to the 7th on the bottom, after I subtract, my x to the 3rd will stay on the bottom. And the difference would be if I switch this, I would subtract, and now it's going to stay in the numerator because I had more in the numerator to begin with. I had 7 in the numerator, so I subtract, and my x, or my variable with the exponent, will stay in the numerator. So when I divide like bases, subtract exponents. So a square root with a variable and exponent, it's pretty straightforward. It's just that we can make these problems as complicated as we want. But the basic idea is not the most difficult to kind of get through. So let's look at one. So say I'm looking at the square root of x to the 6th. That's going to equal x to the 3rd. If I was looking at the square root of x to the 14th, that's going to equal x to the 7th. So what could we say is the rule for a square root with a variable and an exponent underneath? Well, the wording I've come up with is a square root cuts a variable's exponent in half. So half of 6 is 3. Half of 14 is 7. So what would this one be? The square root of x to the 22nd power would equal x to the 11th. So that's all nice and easy to do when our exponent is an even number, but how are we going to deal with an odd exponent? And how we're going to do that is, if I have the square root of x to the 7th, I'm going to say that that is equal to the square root of x to the 6th times x. X to the 6th times x would be x to the 7th. And now I can cut this one in half, so it'll pop out, and then this one stays inside. So I'd have x to the 3rd square root of x. So the 6 got cut in half, that x to the 3rd power popped out, and everything else stayed inside. So say I was doing the square root of x to the 33. Well, I'm going to say that that is x to the 32nd times x. We'll do half of 32. That pops out, and then that will stay inside. So I'll end up with x to the 16th root x. And that's how we can deal with the odd exponents. Now let's look at a more complicated example. So we'll flip over, and we'll do a more complicated example. So let's try this one. Okay, so with this example, what we're going to do is we're just going to take it one bit at a time, going through kind of our steps that we have been working on using all our radical rules. So the first thing we'll do is we'll say, can I simplify the fraction on the outside of my radical at all? Well, we know there's a hidden 1 there, so we just have 1 over 3. So on the outside of my radical, everything will stay the same. Now we can simplify on the inside of the radical. Well, if I look at my 36 over 2, those will simplify, and I will have 18. So I'll simplify the 36 to 18, and the 2 would simplify to 1. So I'll write it in there, but it's not needed. Next, we'll simplify our x's. So I have division, so I'm going to subtract my exponents, and since there are more on the bottom, we will leave that on the denominator. So I'll have x to the 3rd power. 5 minus 2 is 3, and I had more x's in the denominator, so my x's stay in the denominator. Next, we'll deal with the y's. So now I can say y to the 4th over y squared. We'll subtract, and since I have more in the numerator, it's going to stay in the numerator, so I get y to the 2nd power. Okay, so now I'm just going to recopy this so we can look at it. So I have the square root of 18y squared over 3 times the square root of x to the third power. Now what we want to do is look at the square root of 18 and the square root of y squared kind of separately, doing our work separately. So let's do the square root of 18 first. I'm just going to do some side work over here. So we have 18, and we'll draw our factor tree. So I have 2 and 9, 3 and 3. So the square root of 18, 3 pops out, and the 2 stays inside. So the square root of 18 becomes the 3 root of 2. So that piece right there will become, so the square root of 18 piece, this piece right here, becomes our 3 root 2. And then we'll have this y squared piece still right there. Over, and then what we talked about on the front side is when I'm dealing with an odd exponent, I want to split that up. So my 3 will stay the same, and I'll split this up to where I have a x squared and an x. Like so. Okay, a little more simplifying and we're on our way. Since I have y squared, that y will pop out. So I'm just working down. So I'm going to have 3y. So that's that 3 right there. The square root of y squared becomes my y. I'm going to bring the square root of 2 down. Over, I have my 3 right here. The x squared has an x that pops out. So I did my square root of x squared, popped an x out. And then I bring down my square root of x, like so. The 3's will cancel. And then we want to rationalize our denominator. So we'll multiply the top and bottom by the square root of x. So now we'll have the y times root 2 x over x times the square root of, well, x times x is x squared. One last bit of simplifying and we'll be done. So just about everything stays the same. So I'm going to have y root 2x over, this is going to be x times x, because I have my x on the outside, and then the square root of x squared is x. And then one last step to clean everything up, like so. So I just did my x times x is x squared. And that's kind of like the process we're going to follow. It takes some time, takes a little bit of work, but if we break it down and we move slowly, there's no reason to rush. If we move slowly, these things are approachable. So we just simplified our fractions, and then we went through the process of splitting our square roots, rationalizing denominators, and so on and so forth. And that's going to be our final answer. So I want to thank you very much for watching this video, and I hope you have a great rest of your day.